Once again, welcome to our fourth lesson in matrices. Last time we looked at multiplication of a matrix with a scalar, and we said that we don't need to look for compatibility for that. Now, today, I want us to look at multiplication of matrices. That is a matrix with another matrix. When we come to that, when we come to multiplication of a matrix with another matrix, then we have to look for compatibility. Multiplication of matrices. We have to look for compatibility. So for matrices to be multiplied, then for the first matrix, if it is of order m by n, where m and n are numbers, like 1 or 2. And then the second matrix, we are multiplying that with another matrix, which is of order n by maybe another q. If the number of columns in the first matrix is equal to the number of rows in the second matrix, like here, look at the pointer. The number of columns here are n, and the number of rows in the second matrix are also n. So if the number of columns in the first matrix is equal to the number of rows in the second matrix, then those matrices are compatible for multiplication. So we normally check here. The number of columns in the first matrix must be equal to the number of rows in the second matrix. And the resulting matrix, the answer is of the remaining order, m here by q. That will be the result. So this is how you check the compatibility of matrices. When you are multiplying them, you look for the number of columns in the first matrix multiplied by the order of rows in the second matrix. When you are multiplying matrices and you have two matrices, A and B, and you are multiplying them, you expect them to be the same as when you multiply B and A in a normal case, if it were numbers. But that is not the case for matrices. Matrix A multiplied by matrix B is not the same as matrix B multiplied by matrix A. In fact, even the answers will not be the same, as we are going to see. We're going to see that as we move on. So the way the matrix is arranged determines whether it is compatible or not. For example, if I have two matrices here, M1 is of that order, Mn, and I want to multiply with another one of order Q by N. You see, these ones are not the same. So they are not compatible. Simply not compatible for multiplication. I want to write a few matrices and you tell me whether they are compatible for multiplication. There is something that has come up. Okay, first one. Those are two matrices. Look at the order of the first matrix. It's 2 rows, 2 columns. So order 2 by 2. The next one is 1 row, 3 columns, because it's 1, 4, 6. So this is 1 row, 3 columns. So 1 by 3. Are they compatible? Check here. Here you don't have the same number. So the answer is no. The answer is simply no. They are not compatible. So not compatible. What about this? If we had the same as the first matrix, And now we change this to another order. Are they compatible? The first matrix is order 2 by 2. And the next one is order, this is now 3 by 1. Are they compatible? Are these the same? The answer is no. So here, not compatible. What if you have these two, 3, 1, 4, 1. This is a third example. Multiply by 2, 3. Let's check. This is a 2 by 2 matrix. And this is a 2 by 1 matrix. So are they compatible? And I think the answer is yes, they are compatible. You can be able to multiply them. You can be able to multiply them. You can be able to get an answer to that. Let's see, how do you multiply them? I think that should be the next question. How do you multiply them? So the way you multiply is row multiplied by column. Row times column. So we do row times column. It's like we are making a cross. Row, column, row, column, row, column. First row, first column. First row, second column. Second row, first column. Second row, second column. So we will be doing them like that. So let's multiply. So here, when you multiply, you start by first row, 3 goes with 2. So 3 times 2. So you write here 3 times 2 plus 4 times 3. First row, first column. So 3, 4 multiplied by 2, 3. So 4, the second character, is multiplied with the second character in the row. So 4 multiplied by 3. That will be the answer at the top. So you are multiplying first character with the first character. Then you add second character with the second character in the next matrix. So first character in the first row with the first character in the first column. Second character in the first row multiplied with the second character in the second row. It's row times column. I hope you get it. So the next one will be, now we are done with the first row. We come to the second row, which is 1, 1. Let me make this one negative so that you can differentiate. So this will be 1 times 2. The first character in the second row, which is 1 here, 1 here, times 2. Then we'll do plus minus 1, the second character in the second row, multiplied by 3, the second character in the second row. So that is how multiplication is done. So this will be 1 times 2 plus negative 1 times 3. Don't forget the brackets. And what will be the answer? What will be the answer? 3 times 2 is 6. 6 plus 12 is 18. This is 2 plus minus 3, so minus 1. That will be the answer to that multiplication. So look at the answer. Our question, the first matrix was of order 2 by 2. Then, by the way, we have finished there, so don't work further. I just want to show you what I meant. Let me clear this. So the first character, the first matrix was order 2 by 2, 2 by 2. Then we multiplied that with another matrix of order 2 by 1 here. So our answer would be 2 by 1. 2 by 1. Check. Is our answer 18 negative 1 of order 2 by 1? Yes, it is. So that is how you multiply matrices. That's how you multiply matrices. Row times column. Row times column. first character in the first row times the first character in the first column. Second character in the first row times the second character in the second column. And then you add them like that. That's how you do it. I want us to take another example so that we get it right. Huh? Let us multiply 4, 3, 2, 7. Multiply that with 1, 6, 3, 1, 4, 9. Check for compatibility. Tell me whether they are compatible. What if I arranged these matrices this way? Are they compatible? Which arrangement is compatible? Is it the first or is it the second? This is our first. There is a problem somewhere. This is the first. This is the second. Which one is compatible? The first one is a 2 by 2 matrix being multiplied by a 3 by 2 matrix. The second one is a 3 by 2 matrix being multiplied by a 2 by 2 matrix. Which one is compatible? Check. The first one is not compatible, but the second one is. So we cannot multiply them the way they were arranged first. But the second arrangement is compatible for multiplication. Can you try to multiply them and see what you're going to get? So we have 1, 6, 3, 1, 4, 9. We have 4, 3, 1, 7. Then we multiply that. So we multiply the first row with the first column. Hope you get it. First row here, 1, 1, with the first column here. So that will be the way we do it. Let's see. So first row is 1 times 4 plus 1 times 3. That will be the first item we get there. Then we go to the same row, next column. So 1 times 1, and we are not adding here. This is now another character of the second column now. I mean the second column. So 1 times 1 plus 1 times 7. Get it? Then we have another one now. The next, we are through with the first row. We are through with the first row. We go to the second row, 6, 4. So 6 is multiplied by 4 again. This 6, get it very clearly. This 6, the first character in the second row, is multiplied by this 4, the second character. Allow me to change some of these characters so that you don't get confused by the 4s, which are several. Let me put this as 2 and this as negative. Allow me to do that so that you don't get confused. Allow me to put also this one here as negative for the second row. So this will be 1 times 4, 1 times, this will be negative here. 1 times 4, this is, so let's move on. So 6 times 4, 6 times 4, that is this 6 here times this 4. Then plus 2 times negative 3, or this 3 I put a negative. So 2 times negative 3. Then we are done with that first option. Then we go to the same row 6, 2 with the next column 1, negative 1, 7. So 2 times negative 1, 2 times negative 1, plus 2 times 7, 2 times 7. You can see that. So we are done with the second row. Then we go to the third one, 3, 9. So 3 times 4. 3 times 4. So this is first character in the third row times the first character in the first column. There was a plus here. Plus 9 times negative 3. 9 times negative 3. Second character in the second row times the second character in the first column. Then 3 by 1, 3 by negative 1, 3 times negative 1. There's 3 here with the negative, there's negative 1. Plus 9 times 7, 9 times 7. Then you simplify. You get what? This is 4 plus negative 3, that's 1. This is negative 1 plus 7, so you get 6. This is 24 minus 6. Is it 18? This is negative 2 plus 14, that's 12. This is 12 minus 27, you get minus 15. This is 3 plus 60. Negative 3 plus 63, that is 60. That is your answer. The answer is a 3 by 2 matrix, as you can see. That is how you multiply matrices. So we will stop there for now. And I would like you to do exercise 8.5. Exercise 8.5, question number 1 and question number 3. Exercise 8.5 in advancing, question 1 and question 3. Thank you. We stop there for now. Till the next session.